Hey everybody, Ivan Novik here, product management in Broadcom, working on Greenplum today. And this is a lesson called Queries and Plans, how to read plans, how to write queries in Greenplum. This is lesson number 1. And we're going to learn how to write queries, how to analyze query plans or explain query plans and look at the output and how to play with those and even how to provide some hints and change your query plans to modify what you want to do. So let's get started. I'm going to share my screen. You should be able to see my screen now. And I'm going to create a database called airline on the command line of Greenplum. And then from there, this should be an empty database now. T-SQL airline, it's got no tables in it. So let's go ahead and create the schema. I've got the schema here under example 1. Okay, so the schema, let's cat the schema. The schema is basically, I've got a passenger table, which has first name, last name, email, phone number. This is going to be, I'm going to use compressed data. So it's going to be a Z standard compression, row-based storage, orientation. Append only means append optimized or append only. This is a compressed table. In any case, we've got passengers, we've got flights, we've got bookings. We're going to be able to join all this together. And the data I have is also generated by ChatGPT. So there's some good data that we can work with here. Right. So we create the tables. We've now got the tables. So if I go back into airline, you can see we've got 3 tables. Now let's go load the data. When we load the data, it's going to be using copy commands. Copy commands essentially copy the CSV files from the local disk. So let's go ahead and execute these commands into the airline database. Got 100 rows of passengers. We've got 100 rows of flights, and we've got 100 rows of bookings. It's just fake data that I generated here, like I said, on AI. So if we go back in, you can see select star from bookings. No, let's do select star from flight. It's more exciting. See, we're flying from HKG to HND, the flight number, the departure time, arrival time, etc. Okay, now let's run some queries. So I've got a few queries I want to run. Let's look at query number 1. Actually, you know what? Before query number 1, let's look at yeah, fine. Let's go for query number 1. Query number 1. So query number 1 is a basic join. Now the default is optimizer equals on. So technically that's not required, but I want to be really explicit in this lesson whether I've selected Orca, Optimizer, or Postgres Planner. So I'm going to go ahead and specifically request Optimizer, even though it's a default. Now I've loaded the data. Let me do one thing. We do have auto analyze in GP7, but only the paranoid survived, right? So let's just get a bearing of where we are. This is version 7.4.1. Going to run another analyze to just make sure we have stats for everything. And then, yeah. So now, let me run this query first. But what I'm going to do is I want to see if I can do it as a limit 1. Right. So you can see what we're doing. We're taking the booking table and the flight table. We're looking for flights and people who actually booked that flight. We're selecting out the booking ID, the booking date, the seat number, where did the flight come from, where is it going, and when did it leave. Perfect. And if I don't limit it by 1, there are actually 100 rows of matching flights or bookings, because that's what we generated in our data. Now, the point here of this exercise is to look at the query plans. So academically, what we know, this is a join query. So we're going to have to scan the data and we're going to have to join it, bring back the result, right? Now, what does that query plan actually look like? So we're going to run explain. Explain is how we see what the query plan is doing, right? Before it actually executes. And explain won't actually run the query. It'll just show what it would do if it would run it. So what is it going to do? Here is a query plan. Now, this is the fine art, the dark art of reading query plans, which is what this lessons are all about. And this is lesson 1. And this is just, we're going to just get our feet wet. So what has Orca done? Now, a lot of times you might want to think about reading this from bottom to top, but really this is the dark art. So we're going to start working through it. What do we know? We know this is using the optimizer. If for some reason we requested optimizer on and optimizer couldn't handle it, it would fall back and say planner. It did not fall back. It generated a plan. Okay, what else do we know? We know this is a nested loop. What does a nested loop mean? In this case, what that means is we've got 2 tables. We've got bookings and flights. Now, the nested loop, the first operator is doing the scan of the bookings. So the nested loop says, take the outside loop, gather up the data for each item, then for each item, go and do another operation so that you can join it. So basically, for each booking, it's going to, the way you read this plan, what this plan is doing, it's got 50 rows of booking data per segment. So it's 100 rows because there's 2 segments on my system. And it's going to do a sequential scan, which is the most simplistic, just read all the data. Why sequential scan? Well, it's going to read them all, right? Why should it bother with an index or anything like that if it's going to process every row? That makes sense. So it's going to do a sequential scan. There are 3 scans normally. There's a sequential scan, bitmap index scan, or a pure index scan. Sequential scan makes sense if you're going to do them all, because you don't need to bother with an index, just go do them all. So it starts with the sequential scan on the booking data. And then essentially it's going to redistribute that data to all the segments in the cluster. Why? Because it needs to use all the segments to do data processing, right? You don't want to just do this on one segment. And so we push, based on the hash key of the flight ID, these records, these booking records, into a randomized segment, which is hashed based on the flight ID. And then that forms the outer loop of the nested loop. So now, as the nested loop is running, each booking is getting a flight. And as it gets that flight, it says, let me go find the matching booking for it. Sorry. It's reading the booking and then going and finding the matching flight. So each booking, each ticket, and that makes sense if there are 1 million bookings, although the plan could change if the statistics were different, but if there are 1 million bookings, for each booking, go find the flight. So it reads all the bookings. And then here's the inner loop. The inner loop is looking for a flight that matches a certain criteria. Now it's looking for a flight that matches the flight ID of the booking. So it just wants to go directly to that. Perfect. Now bitmap index scan, like I said, we've got sequential scan, bitmap index scan, and index scan. Index scan is faster than bitmap index scan, but one thing that I know is that GP Orca supports bitmap index scan on compressed tables because the table sizes are not they're compressed. They're harder to understand the locations of everything. So it doesn't do pure index scan, although we have that in the roadmap under consideration. We'll most likely be releasing in the near future pure index scan for Orca. But instead, bitmap index scan is good enough. So it's doing the bitmap index scan, it's fetching that flight, and then it's basically bringing it back to the nested loop and joining, and then it's gathering it back on the top. And that's really it. So if I was to run this again, that's what it does. And if I was to wanted to run it manually without the explain and all that stuff, I could show you what it looks like. Here is the join. Here's the booking. but also the booking connected to the details of the flight. Okay, good. Let's look at query 2. How is query 2 different than query 1? So query 2 is the same query, but we have put a index scan hint. Now the hint, to be fair, I've enabled through the create extension. And if you look at the Postgres config file, you'll see that we have enabled this hint. This hint is an extension called PG hint plan. And when I log in here, you'll see the extensions. You can see I've got, I don't have yet hint. I need to install the hint. Great. So let me install the hint. Bear with me here. Let's see, to create the extension for the hint, I'm just asking my trusted friend here online, who's really an AI, for my syntax, because I can't remember everything. Right. So we're going to create the extension. And in addition to creating the extension, what I need to do is, no, I'm good. I created the extension and I've already added this to the configuration data of the cluster. So I've already enabled this shared library, created the hint. So this should be up and running. Great. Back to my point. My point was that we want to run the same query with some hints. So let's see, example 1. What's the difference between Q1 and Q2? We are running a hint. The hint says, essentially, make this an index scan. Now, an index scan is different than a bitmap index scan. There's 3: sequential scan, bitmap index scan, and index scan. The index scan is being hinted here. This comment tells me in this join, use that type of or not this join, in this scan, use this type of a scan. Okay. I also have enabled a debug guck so I can see what's going on, which is set client min messages equals to 1. So let's go ahead and run it. See what we get. What did we get? We got a index scan of the flight table, which is exactly what the hint said to do. So now the optimizer is no longer Orca. It has fallen back to the Postgres planner. Now, the reason for that, I know, I'll just tell you, is because, like I mentioned before, the optimizer doesn't support pure index scan on compressed tables. And I've done that on purpose to kind of just prove that out and test that out for myself. That being said, it was able to fall back to the Postgres planner and make the hint that I requested come true. Now, whether this is a good plan or a worse plan, it doesn't really matter right now. I'm not trying to prove that. I'm just trying to show how to read and manipulate the plans. So what did it do? It made the index scan for the flights, and that kind of changed everything. So what we've got now is no longer a nested loop join. We have got a hash join. So what it's doing is it did a sequential scan on the booking data. And then based on the flight ID, it's redistributed that data and created a hash of it. And then for each item in the hash, it's doing the index scan and basically joining the flight with the booking. There's a little more nuance to that, but we'll leave it at that. For the purpose of showing, I'm not really going into detail of how hash join works in this talk. I just wanted to show you that it is a hash join and that we've changed to the index scan, and that's kind of changed a bunch of things. So we're doing the index scan as the hint said. It forced it to go to Postgres Planner because it wasn't supported in Orca on that hint. And then we did a hash join of the booking table and then it all came back together at the end. Now, option number 3, just to show you one more scenario, is I'm forcing a sequential scan. So let's look at option 3. Option 3, we're hinting, PG hint, to use a sequential scan, same query. And so when we run query 3, let's see what we get. We get, first of all, we do have GP Orca, so it didn't cause any issue. We're still running our default GP Orca. The sequential scan that I requested, right, which is different than query 1, right? Query 1 is the bitmap index scan. That's the default, what the optimizer thought was best. But we forced it or requested it, hinted it to use the sequential scan. So it used the sequential scan on the booking data, which is what was in the hint. No. Where's the hint? Sequential scan on the flight data. Okay, fine. So that's what I would, let's just look at it again. Sequential scan on the flight data, that's fine. It did that. And then it's doing that as a, oh, I'm confusing myself. Let's run this again. So we're hinting it to use the sequential scan on the flight data. And what it did was sequential scan on flight data and sequential scan on booking data. And then basically it's still going with the, still decided to go with the hash join. So it did sequential scan here, sequential scan here, and did the hash join. I think in the next talk, I'll probably do a deeper dive on how hash join is working. But the point here is that you can play with the hint, and using those hints, you can read and see what the query is doing. Go back to query number 1 and just start from the beginning. Query number 1 is the default, and the optimizer did the bitmap index scan on flights. It did the sequential scan on booking and did the nested loop in order to go through each booking and search for the flight. So all of these things change dynamically. There's millions and billions of plans that it may choose. And the important thing is to start to learn to explain your queries and try and understand what's the decisions the optimizers are doing. Does it have good stats? And become a co-pilot here with the database and try and figure out what's good, what's a good plan, what's not a bad plan, and help you be really more of a performance architect. So that's the first lesson. We'll follow this up with the next lesson. So we'll just keep iterating through this and learning how to read these query plans and how to make sense of it. So thanks for watching the first video and look forward to seeing you in the next one. Take care.